My name is Desing I and my matrix number is AE220076. Now I will share about introduction. Camera calibration is an essential procedure in computer vision and image processing that establishes the crucial geometric relationship between a 2D image plane and the 3D real world, enabling accurate spatial interpretation. This process determines key intrinsic parameters and extrinsic parameters while also correcting for common lens distortions such as radial and tangential effects that wrap straight lines. A 9x7 checkerboard pattern with 25mm squares is provided, and processing them using specialized software that is MATLAB camera calibrated application to calculate these parameters and distortion coefficients. This process enhances the reliability and precision of the entire vision system, which is paramount in applications where consistency and accuracy are critical.
Hi, my name is Nur Aina Mardia binti Mustafa, CE 23007, and I will explain the methodology used in our camera calibration project. So for this task, we use 9x7 checkerboard printed on A4 paper with each square exactly 25mm. Secondly, we use smartphone with non-fisheye camera. Then we have a set of 20 calibration images which we take from various viewpoints. And then we have MATLAB camera calibration toolbox. So we began by placing the checkerboard on a flat, non-reflective surface. Then we capture 20 images from different angles, distances, and perspectives. During the process, we follow several important conditions, which is the checkerboard must be fully visible in each image. Lighting must be even, avoiding any glare and harsh shadow. Images were taken with tilt, rotation, height angle, and side angle to allow MATLAB to estimate the parameters accurately. All images were checked to ensure the corners are sharp and the pattern was in focus. This ensures a reliable detection during calibration. So what we need the intrinsic parameters where it describes how the camera forms an image internally. And then we have the distortion coefficient, which is the K1 and K2, where most real lenses cause the slight bending of straight lines. And this is also known as radial distortion. And the third we need is intrinsic parameter, where it describes the camera position and orientation relative to the checkerboard.
Assalamualaikum and a good day, doctor. So I will continue for the methodology part, but this one is for demo MATLAB. So my name is Hafa binti Alias, CE230026, and here we are using MATLAB 2025. To do the calibration image, we need the apps, which is called Camera Calibrator. So if we did not have this in MATLAB, we can install this at install app. So the first step is we need to open the camera calibrator, and here is the window for camera calibrator. So to get a good result, accurate result, we need to upload the image, at least 12 image. That one is minimum, but the more the better lah. So to add image is you can choose this, whether it is already on in your laptop, or you can use camera MATLAB. For me, I already saved the file, so I open the session and choose this one. When you upload the image, it will ask you for the size, and we will choose for 25mm. And here the image, I load all 20 images into MATLAB. And we also have different angle, also the blurry one, because we want to test the calibration in the MATLAB. Here is for the camera model. For us, we do not use fisheye because we use smartphone. We choose for standard. If you use a fisheye, you can choose for fisheye, and do not forget about this. Because we use standard, so we use 2 coefficient. So for the fisheye, maybe you can use 3 coefficient because for wide field of view cameras. And after you upload all the image, you click the calibrate, and when it's finished calibrate, you can see it automatically detect the checkerboard. You can see the green dots marking the detected point and pattern origin, and also reprojected points. This part runs the camera calibration. Here, after you've done calibrate, here you can see the reprojection error of raw mean is 0.8, which kind of accurate lah our calibration. And here is we have camera centric, and this one is pattern centric. You can see this one is our checkerboard, and this all the camera angle. And next, we export these parameters to workspace, and okay, yes. Here you can see your camera intrinsic, and also accuracy of estimation, calibration settings, and camera extrinsic. But to see standard of mean error, we need to generate MATLAB script. But before I do that, here I show you this one is a distorted image. If you use fisheye, when you click the show undistorted, you can see the difference between distorted and undistorted. And for our picture, we see the lines, we can see the straight lines look more accurate after the correction. And if you use fisheye scale, when you click show undistorted, you can adjust your fisheye scale here. But right now we use standard, so we cannot adjust the fisheye scale. And then after that, we generate MATLAB script. So we get the program here. Yes, this is the program. And for the first is this part lists all 20 images used for calibration. So MATLAB needs this file so it can load and process each image. And for the next part is image point, image use, which is this one. MATLAB automatically detects the inner corner of the checkerboard pattern. This is important because calibration is based on matching this corners point between the image and the real world checkerboard lah. So this one is square size. We tell MATLAB that each checkerboard square is 25 millimeters. And the next one is calibrate the camera. So this is the main calibration, because here we calculate the intrinsic parameters such as focal length, principal point, and also the distortion coefficient K1, K2, and the extrinsic parameter for each image. So we also set the calibration to use 2 radial distortion coefficient, which is standard for non-fisheye cameras. Like if you use fisheye, you can choose 3 coefficient. And undistorted, to remove effect of lens distortion, this one, it allows us to compare the original distorted image with the corrected image. So I think that's all for the program. And now we can run to get the figure output, also the standard mean of reproject error. So let's put this as calibration group 4. Here is the figure mean reprojection error per image. So overall mean error is 0.8 pixel. You can see here is the highest mean reprojection error per image. And for the figure 2 is extrinsic parameter visualization. And for the last part is this one, standard errors of estimated camera parameters. So you will get all the calculation for intrinsic, extrinsic, and this one is the value, the output for each of the part calibration. And I think that's all from.
So the main outputs we have here is the intrinsic parameter where there are focal length and principal point. So the focal length we have 902 until 912 pixels, where it shows how much the camera zooms in horizontally and vertically. A higher value means stronger zoom, and for CX and CY is 321 pixel and 240 pixels respectively. This is the optical center of the camera sensor. Ideally, it should be near the center of the image, and our results show a small offset, which is normal for real cameras. So for K1 and K2, K1 it corrects distortion near the image center, and K2 corrects distortion near the edges, and we have 0.08 and 0.35, which the positive indicate barrel distortion where lines appear to curve outward. And for our extrinsic parameter, it describes the camera's position and orientation relative to the checkerboard. So, in conclusion, we validated the accuracy through the reprojection error and undistorted image result. And we could clearly see that the lines became straighter and the lens distortion was corrected. So this shows that the calibration worked.
Assalamualaikum, my name is Intan Anis binti Azman, CE230025. So today I will present about the result and discussion. So as we can see from the graph for mean reprojection error per image, most images show low reprojection error, which is 0.8 pixel, indicates a stable intrinsic calibration. So only for the image 20 have higher error, which is 1.8 pixel, due to lighting, extreme angles, or incomplete corner detection. So overall, it indicates an accurate, reliable camera model with strong feature alignment. So for the next one, we can see here the extrinsic parameters visualization in 3D space. So as we can see, all the poses are well distributed in 3D space, which providing good geometric. It also support an accurate estimation of rotation and translation parameters. Some of the clustering need more extreme angle image to improve coverage. With this consistent and accurate calibration, a few frames could be refined.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azum Rosli. So this is the part for SDG, and there is 3 that reliably contribute to this assignment. So the first one is industry innovation and infrastructure. Giving the accurate camera calibration strengthen the foundation for innovative technologies such as robotic, automated inspection, and smart manufacturing. The properly calibrated vision system improve measurement reliability and reduce defect during production. And then there's also the responsible consumption and production. This contribute by giving by decreasing the waste and giving the resource consumption as low as possible, and make the technology practice more sustainable and responsible. And the last one is sustainable city and communities. By giving the camera calibrated support smart city applications such as traffic monitoring, structural inspection, and environmental mapping. This will, with the accurate spatial interpretation, ensure the safe and more efficient urban system. Now for the conclusion, this calibration process by using a 9x7 checkerboard successfully produced accurate in strict parameters, distortion coefficient, and projection error analyzing for the smartphone camera with a mean projection error of 0.8 pixel. The result confirmed that the camera model is reliable for measurement, tracking, and image-based consumption. Thus, the diversity of viewing angle and distance contribute significantly to the calibration accuracy by ensuring strong geometric variation across all frames. Even though with certain frames show slightly higher error, overall performance remains stable and sufficiently precise for typical computer vision application. So that's all from me. Assalamualaikum warahmatullahi wabarakatuh.